Hello my dear students, welcome back to Learn Physics. In today's topic, we are continuing with our moving charges and magnetism chapter. Today is the last part of this chapter. Okay, so in last video, I gave one homework for you, which was two small identical circular loops marked 1 and 2 carrying equal currents are placed with geometrical axes perpendicular to each other as shown in figure. Find the magnitude and direction of the net magnetic field produced at the point O. Okay, so here we need to find out the magnetic field at the point O due to this one and this one. Due to 1 and 2. We should find out. Both are from the same distance from the center. Okay, so this is at a distance x and this also at a distance x. So magnetic in a current carrying coil, what will be the magnetic field at a distance x from the center? Having a radius r is the radius or a is the radius. B equals mu 0 by 4 pi into 2 pi n I a square divided by a square plus x square the whole power 3 by 2. This is what we learned, right? B equals mu 0 by 4 pi into 2 pi n I a square divided by a square plus x square the whole power 3 by 2. Here we don't have any values, right? So instead of this mu 0 by 4 pi and all, we can cancel and we will get 2 here, and here only one coil is there. That's why mu 0 by 2 into I a square divided by a square plus x square the whole power 3 by 2. This is the formula for finding out the magnetic field. Now for the coil 1, in which direction magnetic field will be acting? Current is moving in this direction, magnetic field is towards this B1. And what about current B2? B2 will be acting in this direction, right? So current is moving in here and magnetic field is acting in the upward direction. So magnetic field will be acting in the upward direction here, B2. So we need to find out the value of B1 and B2. B1 will be equal to mu 0 I a square divided by 2 into a square plus x square the whole power 3 by 2, and B2 also, since the radius is same, a is the radius if I am considering, a is the radius here and x, the value will remain the same for B2 also. Then how we can find out the net magnetic field? B1 is a vector, B2 is a vector. Parallelogram law of vector addition we can use. How? This is the value of B. Okay, B1 and B2 are perpendicular vectors. So root of a square plus b square plus 2ab cos theta. What will be cos 90? Cos 90 is 0. Therefore root of b1 square plus b2 square. B will be equal to root of b1 square plus b2 square. Okay, b1 and b2 are same. So we will get it as 2 root 2 b1. Therefore, the value is root 2 into mu 0 I a square divided by 2 into a square plus x square the whole power 3 by 2. This will be the value of magnetic field. This root 2 and 2 you can cancel and you can write it as divided by root 2. Now we need to find, this is the magnitude. Now we need to find out the direction. Direction, how we can find out? See, this is theta. Then you can take the value of tan theta. Tan theta will be equal to opposite side divided by adjacent side, B2 divided by B1. Okay, so B2 by B1 both are same. So tan theta equals 1. Therefore, theta equals, yes, theta equals tan inverse 1, that is pi by 4, 45 degree. Clear? So the next one, two identical coils P and Q, each of radius r, are lying in perpendicular planes such that they have a common center. Okay, both the coil are having a common center. Find the magnitude and direction of magnetic field at the common center of the two coils if they carry a current equal to I and root 3I respectively. So here we are considering two circular coils. Both are having a common center. So if both are having common center and current is passing through it, I root 3I are the current which is passing through it, and which are lying in perpendicular planes. Okay, two coils are lying in perpendicular planes, but they have common center. Okay, one is like this and the other is like this. So both are perpendicular, but their centers are coinciding. Clear? So their centers are coinciding and they are lying in the two planes, perpendicular planes. So here magnetic field, as we said in the previous cases, here also magnetic field will be same, but here the point is at the center itself. So here B, due to the magnetic current I in a circular coil, B we got it as mu 0 by 4 pi into 2 pi Ni A square divided by A square plus x square the whole power 3 by 2. Okay, perpendicular planes only. So the same way which we did in the last numerical, same way we can do here. But x, what will be x here? At the center of the coil. That means it is not moving any distance. X will be equal to 0 over there. So this one we can write it as 0. Here we will get it as mu 0 by 2. N is 1 I A square divided by A square the whole power 3 by 2. A square the whole power 3 by 2 will be A cube, mu 0 by 2 I by A. This will be the magnetic field. Okay, now we should consider the direction. So perpendicular means it will be considering. Here, what is the value of I in both the cases? In first case, the first coil current is I and the second coil current is root 3I. So what we will be getting? Mu 0 by 2 into I by A for first one, and second one mu 0 by 2 into root 3 into I by A. Okay, now B will be equal to, it is having a difference of root 3 here, root of B1 square plus B2 square. While we are taking it out from the inside the root, mu 0 I by 2A will be coming inside, and here, see here, 1 plus root 3 the whole square is 3. Okay, then we should take the square root. So we will get it as mu 0 I by A. Now we can find out the angle tan theta. How we can find out tan theta? Tan theta equals B1 divided by B2. In the previous one I showed you how we are doing B1 by B2. So while we are finding out B1 by B2, we will get it as 1 by root 3. So what will be theta? Theta will be equal to tan inverse 1 by root 3, which is equal to 60 degree or pi by 3. Clear? Next one. An electron moving horizontally with a velocity of 4 into 10 to the power 4 meter per second enters a region of uniform magnetic field of 10 to the power minus 5 Tesla, acting vertically upwards as shown in the diagram. Draw its trajectory and find out the time it takes to come out of the region. Okay. So here in this question, electron is moving horizontally with a velocity of 4 into 10 to the power 4 meter per second. This is the velocity of the electron and enters a region of uniform magnetic field, that is equal to 10 to the power 5 Tesla. Minus 5 Tesla, and acting vertically upwards. It is acting vertically upwards. So like this it will be acting. Then draw its trajectory and find out its time it takes to come out of the region of magnetic field. Okay, so what will be the direction of movement of this electrons? In which direction it will be moving? This electron will be see, velocity is like this. It is acting in the upward direction. So the electron will be using Fleming's left hand rule. We will get that electron will be moving in a anti-clockwise direction. Right, V is here and B is acting vertically upward direction. So it will be moving in the anti-clockwise direction. So when it is moving in the anti-clockwise in a uniform magnetic field, when it is entering, it will be following a circular helical path. Velocity V cos theta will be acting like this and V sin theta will be acting upward direction. So it will be, there's a helical path it should follow. But here magnetic field is acting in the upward direction and velocity is acting in this perpendicular to that. Right? Magnetic field is acting upward direction and velocity is acting in this direction. So this will be following a circular path. Okay, it is following a circular path. If it is following a circular path, then force due to magnetic field will be equal to mv square by r. So we will get it as qvb will be equal to mv square by r. V and V will get cancelled. QB equals mv by r. What is our aim? Our aim is to find out the time. Time, how we can find out? See, time will be equal to distance covered by time will be equal to velocity. So time will be equal to distance covered divided by velocity, that is pi r divided by V. Okay, here we will get it as pi into, see V, how we can find out V from here? From here V will be equal to QBR divided by M. Therefore, pi into R divided by QBR by M. M and M will get cancelled. See, we have mass of electron, we have pi M divided by QB. Pi value we know, mass of electron we know, charge of electron we know, and the magnetic field value also we know. We can find out the time period. Okay, clear children how we are finding out this value? Next question is, state the condition under which a charged particle moving with a velocity v undergoes undeflected in a magnetic field. And along with that, a second question also there. An electron, after being accelerated through a potential difference of 10 to the power 4 volt, enter a uniform magnetic field of 0.04 Tesla perpendicular to its direction of motion. Calculate the radius of curvature of its trajectory. See, state the condition under which a charged particle is moving with a velocity of v undergoes undeflected in a uniform magnetic field. Charged particle is moving in a uniform magnetic field, then it is moving undeflected. That means no force is acting on the system. If no force acting on the system, F is equal to Q into V cross B. That is equal to 0. That is QVB sin theta equals 0. Then what will be the value of theta? Sin theta, it will be equal to 0. That is theta will be equal to 0. That is angle is 0 degree, or we can write it as it will be equal to pi. Okay, or plus or minus n pi. In general we can write it as theta will be equal to plus or minus n pi. Okay, this will be the value of theta. Clear? Then next is, an electron after being accelerated through a potential difference of 10 to the power 4 volt enter a uniform magnetic field of 0.04 Tesla. So the potential difference is given as 10 to the power 4 volt. Magnetic field is given as 0.04 Tesla perpendicular to the direction of motion. Both are perpendicular. Calculate the radius of curvature of the trajectory. So how we can find out? So mv square by r is equal to qvb. So here v and v will get cancelled. mv equals mv by qb equals r we are getting. Okay, mv by qb equals r. What is mv? mv is p, momentum. Right, p divided by qb equals r. We know p square by 2m equals q into v, potential. Okay, in term, because we have potential here, velocity we don't have, right? So here p square, from here p we will get it as root of 2m qv. So here instead of mv we can substitute as root of 2mqv divided by qb. Mass of electron we know, charge of electron we know, potential we have, B we have. You can find out the value. While you are finding out, you will get it as 8.4 into 10 to the power minus 3 meter. 8.4 into 10 to the power minus 3 meter you will get. So try to solve. Okay, this is how. So if momentum is not, see mv, here velocity is not given. So which formula will be including mv? The velocity. That formula we should find out, including potential. Okay, this one 2017 question only. So these are some of the previous year questions I discussed. So using this you will be getting n number of questions in net. So please try to solve all the questions and be thorough with the chapter. Okay, next class we will be continuing with the next chapter. Okay dears, thank you. And one more thing, if you like the video, please don't forget to subscribe, like and share.